Okay, so today, I think in the presentation, I'm going to talk about the mini project I have been working on. So the dataset I'm going to use is the secular dataset, including the breast cancer. And the goal is to pretty much to use random forest to predict whether the breast cancer is benign or not. And the focus, however, is to talk about how we can interpret it a prediction um, using two ways. One is called Lime, the other is called SHAP. And TLDR is that the Lime is simpler and more human readable rules around one prediction. SHAP is really based on the Shapley value attribution and with the global and local views. So for our model, the like TLDR is that we found the worst area, concavity, and radius dominates the decision whether it is a benign or not. And another thing is Shep is more stable, Lime is more kind of storytelling for the clinicians. Cool. Okay, so we can start from the Lime. So the Lime on the left hand side is a little bit small, but on the left hand side, it says malignant with a probability of 1, which is the blue bar over here. And the middle is the blue bars, and the features basically push into malignant. Orange is like to the benign, and each rule is basically the local decision boundary. So larger the bar, regardless of whether it's blue or orange, the larger that feature's impact on the patient's malignancy score. So whether it is breast cancer or not. And the table at the bottom lists the actual values. On the other hand, sharp value, which we can look at from the waterfall plot. So the baseline on the right is the average model output over all the patients, and the blue blocks show basically how each feature moves from the baseline to the patient's prediction, like individually. So the rightward contribution increase the malignancy probability and leftwards decrease it. So from here, we all see like um, it's decreased. So like worst area decreased by 0.08, worst concave points decreased by 0.07. And we kind of lumped together 21 other features here, and in total it gave us about negative 0.60. So in this example, we know that the high worst area and the concavity related features strongly push to malignant. Another kind of great feature from SHAP is that you can visualize the interactions between features. So here is just a quick example of like the mean radius and the mean texture of the picture. And each point is a patient. So similarly, the color and the position reflects the influence, but here is more like the joint influence on the predictions. So it helps us to recover some nonlinear pattern, like interaction patterns between some of those features, and it can complement Lime by showing how groups of patients behave, not only just one case. So again, I want to conclude here that we made the comparison between Lime and Sharp, especially under the kind of this machine learning prediction model. So the pros of the Lime is like it's very interpretable, very easy to show like kind of clinicians, like people who probably are not really data savvy. The cons is like the explanation can change with different sampling. So there's no global picture over here. Compared to that, the pros of Sharp is that it's theoretically grounded, so it's based on the expectations and all those more fundamental statistics. So it has a consistent global rankings and richer plots. The count is probably it's gonna be slower to compute. And the visualization, to be honest, is a little bit harder to explain to non-technical audience. So last one is kind of just the project takeaway. So for this breast cancer model, so both methods actually point to the similar features. So worst area concavity radius, which is consistent. And again, lemma is great for case-by-case storytelling. Shep is better for auditing the model as a whole. And as for next step, I think measure the explanation stability extent to fairness subgroup analysis can be something that we can do in the future. But yeah, so here is all the presentations.